Hello everybody and welcome back. We will continue learning Java design pattern. As we have learned in our previous videos, we talked about observer design pattern, we talked about factory design pattern, correct? In today's video, we'll discuss about command design pattern. So here are the objectives. To learn command design pattern that allows to create standalone objects for processing specific action as and when required by the user, correct? And it is typically a behavioral design pattern, and it allows encapsulation of request as an object. It decouples the request invoker from the request operator, and it allows a common interface that can be used across application to perform actions on the operator. Correct? So command design pattern is type of a behavioral design pattern, and it is used for encapsulation of request, and your request can be from any UI button action, or it can be from any client calls. Correct? It helps us to encapsulate that request as part of an object, and that object will invoke the final operation. Correct? So this basically helps us to decouple the request invoker from the request operator. Correct? Now what are this request invoker and what are the request operator, we'll get to know when we'll code this. Some of the common examples is a common example to illustrate a command design pattern usually is we use bank account example. Here we will have a bank account class which will be a receiver and which performs certain operation. As you might have understood, bank account class, right? So certain operations would be deposit or withdraw, correct? Then we'll have a command interface with an execute method. Then we'll have a concrete command interface which makes reference to the receiver bank account class. Finally, we'll have an invoker or a client main class. The client main class can be any UI or it can be any desktop application, but this is how it works, correct? So let's look at this common example and illustrate the command design pattern in Java. Let's code it. Moving back to IntelliJ. So here in my project, I've created a package called pattern and a package called command. Here let's go ahead and build our receiver object. The receiver object would be a bank account class, correct? And this bank account will have a private integer value balance, correct? Then let's create the constructor of this class. This would be the basic constructor. Then it will have a public integer deposit withdraw method or deposit method. Let's say this is a deposit method. Takes in an argument of input amount and returns the balance plus amount, correct? Let's, instead of returning the balance value, let's print out the result. Correct? No need to, so this would be void, no need for a return type. Let's have a withdraw method. Withdraw balance would be plus minus amount, withdraw will be plus minus amount, correct? So this is our basic receiver object class called bank account, and this bank account class has two operations, to deposit and to withdraw, correct? In normal way, in normal application, what you will do is you will have a client application. Your client application will make an instance of your bank account object and then it will invoke the deposit or withdraw method, right? This is almost correct in most of the examples, but having this tight coupling between the client code and your bank account class, which is the receiver, which does the final operation, is not that flexible when it comes to reusing your code in your application, right? So an immediate solution to use is we'll have a decoupling, and to achieve this decoupling we'll have a new object, and that new object will be supported with the help of an interface. So first I'll define an interface called command, correct? And it will have a single method called void execute. Then we'll define a class called bank account command, which implements this command interface and has a reference to this bank. So in order to add the reference, we'll add a private member of bank account and name it as bank account. Let's implement the execute method. Correct. Now I'll define enum called action, and our action can be of two type, and action indicates a request action, right? And this request action can be received from your client calls also. So enum action, this would be deposit, withdraw, correct? Okay, there's a mistake, deposit. So this enum has two variables, deposit and withdraw. Let's go ahead and construct this particular bank account command. The bank account command will accept this, and it should accept an action and accept a amount, correct? So basically, when this bank account command object will be created, we'll be passing a bank account reference, then we'll be passing in the action, whichever action it wants to perform, either withdraw or deposit, right? And an amount. Let's now have a switch statement to the execute method. Switch statement will check for the action. Let's also define the action as a member to this class, then private int balance, correct, which we are constructing in this method, constructor method. Then based on the switch class, if there is a case of a deposit, then we will invoke that receiver objects, which is the bank account objects method or operation called deposit, correct, and break the statement here. Then we'll have a case for withdraw. Let's reformat this code. We follow the indentation as per the coding. Then invoke the bank account withdraw statement and break, correct? So let's revisit what all things we have done. We have defined a receiver object, or this would be our receiver, correct? Then there is a command interface, which we have named it simply command, and it has a single method called execute. Then there is a concrete method, concrete command interface, which holds reference to the receiver object, correct? Receiver object in this case is bank account. This is clear. Then there is a simple implementation of execute method based on the action. It will invoke the receiver objects implementation. Then there is a construction method. Now let's try to demonstrate that with a class called demo. We'll have a main method here. Let's define a bank account, which will be initially 0. So need to define a constructor also. Let's say opening account, let's say 10 amount. So initially it's opened with a 10 as a default value, correct? Then instead of directly calling the bank.deposit account like this is a direct call. Instead of using this, what we want to is we will avoid making the direct call, because this makes a strong coupling, and then can it lead to a lot of issues such as code reusability is reduced, security reasons are there. So in that case, what we will do is we will prepare a list of commands, and the list of commands will be bank account commands, correct? Let's import the java.util.list package. Then we'll name this as bank account commands and new array list. Then let's add So let's do, instead of using this new array list style, let me use the factory method, list of, and then here we'll define new bank account command, and it will accept a bank reference, that is the bank account. Then it will have an action called withdraw, so it will be action dot withdraw dot, let's say I want to withdraw 5 rupees. Then define a new command, bank account command, bank account command withdraw, no, this time we'll deposit. Then it would be, say, 15, correct? So these are the list of commands, and this list of commands we could have received from any third party or any UI application. It can be from any web application, it can be from any client application, any React application. So this will be the input, and basically we're maintaining a list of command. And when we maintain this list of command, if we revisit this particular node, correct, and this will help, basically it's not written here, but yeah. So just to understand what this is doing, it is maintaining the list of command. This list of command can be stored within your application for, let's say, certain period of time. Let's say your application has a period of 1 minute, so we can hold this list for 1 minute, either in a queue, either in a DQ, or either in a list. And then once the time is done, it can schedule this, and after certain time it will pick one command and execute it. Now we have prepared the list of commands. Let's see how would we execute this. So in order to execute this, we will first let's want to iterate through each command, and based on that command we will invoke the interfaces method called command.execute. Correct. Now let's print out the bank details, and that we will understand what are the changes. Before printing that information, I have not implemented the toString method. So let me quickly generate this with the help of IDE, the toString method. And now if I run this application, we'll see initially it should be sysout bank account. Let's run this now. Okay, there is an issue, cannot invoke action.ordinal because this action is null. Withdraw and deposit new bank account. Alright, I've not, because there's issue because we haven't initialized this, right? We haven't marked this action or initialize it to the member variables. Now let's rerun this. Now let's see, we can see the printout, right? The bank, when the account was open, it has an initial value of 5, then it received a withdraw command with the help of the bank account command. So here see withdraw 5, balance is now 5. Then your bank account changed to 5 with a balance of 5. Then it received a deposit command of 15 and the balance got added, thus the bank account is changed to 20. So this is how the command design pattern works in Java. And the advantage of this is, here we are creating loose coupling. Loose coupling helps the code to be reused a lot. For example, you can reuse this command interface and this execute method not only just in this example of bank account withdrawal and deposit. You can use in many other transactions also. Like you want to check your CIBIL score, you want to check your investment status, you want to check your credit score, and you want to transact some value, you want to check your statement. So based on that action, we can reuse this command class. Only need is we need to implement this command class and have its own implementation. Because of this loose coupling, the code reusability has increased, right? So these are the advantages of command design pattern. I hope you have understood this. I will try to extend few more information. Yes, so here is a diagrammatical representation of command design pattern. Basically the motivation is, ordinary Java statements are perishable, so we cannot undo a field assignment and cannot directly serialize a sequence of action. And this is something which we can learn in the next session. This talks about undoing some of the actions. Like if we want to undo some task, we can use this particular command design pattern. But to understand the simple example of bank account, here is the command pattern diagram. First we have a command interface, then we have a concrete command, then there's a target, right? So target was basically the receiver object, the bank account class. Then we have a client, right? Client and invoker communicates and then invokes this execute method. Because this execute method was implemented concrete method in turn will know, okay, what this particular action is. Based on that action it will call the method. So this is how the command pattern works. To more correlate, we should know what are the common implementation of command design pattern in Java JDK. So if you are a Java developer, you should know what all other classes in already provided Java objects use it. So command design pattern is widely used across different libraries in Java JDK to encapsulate operation as object. Some of the most common implementation include a runnable interface. Correct. This is highly used in concurrent threading and executor framework. Right, when you want to do asynchronous programming or concurrent parallel programming Java, we use heavily the runnable and executor interfaces, which again uses the same command design pattern. Then if you are doing some Java FX or Java X swing application development, then there is an action for GUI actions, then there is a timer task for scheduling tasks. Stream operations are also using command design pattern internally. So for you, you don't have to code all these complexities, right? It's already provided by JDK, but if you know the command design pattern, you can implement and use in a real world example such as this banking application, right? So this is it. I'll try to explain few of the implementations. This implementation such as runnable interface is a great example of command design pattern. The command is encapsulated within the run method, right? If you remember, runnable interface as a single run method which is used for running the task on a different background and the thread, and that command to run it is again done and all think together with the help of command design pattern. Then there is the executor interface. The executor interface is another example of command design pattern in Java JDK. It defines a method called execute which accepts runnable object and executes it. Again, there is a streams API example which uses the same command design pattern, and it has operations such as filter, map, reduce, etc. So I hope you are clear with this command design pattern. It is very simple, and thanks for watching this video. I hope you have learned something new in your journey to becoming a better Java developer. If you have any doubts, please mention them in the comment section, and if you have not subscribed, please subscribe. We'll be presenting such more videos revolving around Java development and Python programming also in near future. So thanks for watching this video. Have a nice day.